In this video, we're going to be taking a look at the periodic table. At first glance, when you see the periodic table, you might think that if it's just a bunch of elements randomly put in a specific order just to have a chart of every element that we have. However, it's much different. There's actually a very particular reason why each element is in that exact spot. As we can see right off the bat, in the periodic table that we're using today, there's different groupings. So we have alkali metals, alkaline earth metals, lanthanoids, actinoids, transition metals, poor metals, other non-metals, and then noble gases. So this group right here is going to be your alkali metals. This group right here is going to be the alkaline earth metals. Down here are going to be the lanthanoids. Down here, it's going to be the actinoids. That's going to be the transition metals. Poor metals are this turquoise looking color. And then we're going to have the non-metals right here. And then the noble gases right there. These groups, there's 18 different columns. However, there's only a particular name for 8 of those columns. This column right here, the alkali metals, are going to be group 1A. Right here, this second column, the alkaline earth metals, are going to be group 2A. And we skip over all the way right here. This column with boron that goes straight down, column 13, is going to be labeled 3A. The column with carbon is going to be 4A. The one with nitrogen, 5A. The one with oxygen is going to be 6A. The halogens right here are going to be group 7A. And the noble gases are going to be group 8A. And the reason it's like this is because every single one of these in this particular group has the same number of valence electrons. In group 1A, they all have 1 valence electron. In group 2A, they have 2 valence electrons. 3A, they have 3 valence electrons, and so on. All the way to the noble gases, which have a full shell or 8 valence electrons, except for the one exception of helium that only has 2 valence electrons because it has not yet had the outer shell that is able to contain 8 valence electrons. Another thing that we can take a look at is the periodic table right here. Each element has a particular set of numbers within its little box. So the example that we're using today is helium. And as we can see right here is going to be the atomic number. He is the abbreviation for helium, the name helium, and then its atomic mass. And this is an average. If you watched the previous video on atomic structure, we talked about how the average is set forth because they get an average of all of the helium atoms out in the world. So if there's if there's helium atoms with a mass of 4 in the world, and that's the biggest portion of helium atoms, the average is going to be way closer to 4 than it would be to another number. So the atomic number can count for either protons, it'll give us the number of protons, or the number of electrons. So protons or electrons. Helium's the abbreviation again, the word helium. And then the mass at the bottom is in AMUs. And what that accounts for, that's going to be our protons. So we had 2 protons. And then it'll be 2 protons plus the number of neutrons. And since the mass is 4, we have 2 protons. We know that there's going to be 2 neutrons. So 2 neutrons. And neutrons don't have a charge. And I drew the atomic structure of helium right here. So as we can see, there's the 2 protons, 2 neutrons, and the 2 electrons. The atoms within the periodic table are ordered by atomic number. So this means that as we increase, as we go from right to left, and then when we get to the end, we go to the next row, as we increase the atomic number, the number of protons increases. And if it's in a neutral state, the number of electrons also increases proportionally. So if we take a look at another example, right here, we're going to be taking a look at lithium, the very next element on the periodic table. So right here we have lithium. It has an atomic number of 3. It has a mass of 6.9, and that's the average. So what we could see is that most of them are going to be at a mass of 7, but then we'll have very few that are a mass at 6. So then the average in the world comes down to 6.941. And then we can draw in the rest of the protons, neutrons, and electrons now. So we have 3 protons. So let's, gotta change the color. So we have 3 protons. We have a mass of 7, and there were 3 protons, so we can assume there's about 4 more on average neutrons. So that'll give us that's 6, and then 1 more. So that's 7. And then we have 1 more electron. And this inner electron, this shell was completely filled, so we have to go to the next one. And on this outside part, we'll draw, on this outer shell, we'll draw the next one, the next electron. So there's our 3rd electron. And as you can see, there's only 1 electron now on the outer shell. So that means that lithium has 1 valence electron. And if we go back and check, right here, lithium is in group 1A. Let me bring this up so you can see. Lithium is in group 1A, therefore it only has 1 valence electron. And if we went to beryllium, we would add 1 proton, 1 electron, and that electron would be, again, on the outer shell. So it would be drawn right here. And then beryllium would have 2 valence electrons, so 2 on the outer shell. So now going on to the last bit that we're going to be talking about today. The elements on the periodic table are divided into 2 big groups, you could say. There's going to be the nonmetals. And then the metals. And then the nonmetals are going to be everything right around here. So if this will work. So the nonmetals are going to be all right here. And then the metals are going to be the rest of the periodic table. And then in another video on ionic and covalent bonds, we'll see that anytime you have a nonmetal, so I'll put the abbreviation NM, bonded to a nonmetal, this will be known as a covalent bond. And then anytime you have a metal bonded to a metal, this will be known as a metallic bond. All right, that's it for today's video. Thank you for watching.